Hey guys, we're going to pick up our discussion on light today with diffusion. And diffusion is when parallel rays of light hit a bumpy surface. And I want to talk about what parallel is. That's when lines stay the same distance apart. In this case, light waves, lines in math, whatever. They never get closer together, they never get further apart. They're the same distance all the time. So when they hit a bumpy surface like you see here, okay, they're going to reflect, okay, but they hit at different angles, okay, because of the bumpiness. So that scatters the light or diffuses the light. So if you see that term, that's because it's hit something that is not flat but bumpy. Okay, now we're going to look at refraction. And refraction, we've discussed a little bit. It goes along with reflection, okay? And it is when light waves enter a new medium. Remember, during sound, we talked about medium being a solid, a liquid, or a gas. So when it enters a medium at an angle, the speed changes. So if we look over here at this glass, the air is a gas, okay? The water is obviously a liquid, okay? So when the light hits it, it changes the speed. So the change in speed of the light wave causes the light waves to bend or change direction, which then gives the appearance in this case that the straw is bending. So if you want to look at this graph here, that's what's called the index of refraction. And that's how much the light ray bends when it enters the material. So you see the light ray coming in, it hits a new material, in this case, air to water, so it bends instead of going in the direction that it was headed. Okay, some more things with refraction. And now we're going to start talking about different lenses. So again, when light is traveling in those straight parallel lines, you'll notice no closer together, no further apart. And it passes through something that is curved like a glass lens. The light is refracted or bent at different angles. So there's two types of lenses. One is called convex or converging. Converging meaning coming together. Okay? So a convex lens would take all of the light rays and converge them into a central point called the focal, meaning what you're focusing on. Okay? Then conversely here, we have what's called a concave, and you'll notice how it's designed to almost exactly opposite of the convex lens, and that bends the light outward from the focal point. So you can see the lines here going outward in different directions. Okay, now we're going to talk about when light is absorbed or the absorption rate. If light does not pass through or reflect on a material, but it stays in the material, it stays as energy. So if you look here, here's our Roy G. Biv, red, orange, yellow, and a black surface. Up here we have an example of a man in black clothing. Okay. The light is going to absorb or collect in that black surface. So think about to yourself, what would happen to that black surface? Think about if you would have all black on a really hot day. Okay, we're going to look at some colors now. Objects reflect the colored light that is not absorbed. So if you will look here at these examples, this blue object, the blue is reflected. Okay, so that is what our eyes see, the reflection of the blue. Same thing with the red. The red is reflected, so we see red. Okay. Down here, the black is when all the colors are present. It appears black to us. Okay, now we're going to look at the different colors of light. There's different categories. First one is called primary. primary colors. Probably heard it in elementary or whenever you had basic art. There are 3 primary colors: red, green, blue. Okay? When they're combined equally, this is sort of like a Venn diagram over here. When they are combined equally, so the same amount of red, same amount of blue, same amount of green, you get white. But if they're combined in different amounts, you get other colors. So for instance, the red and the green would make yellow. Okay, so those are your primary colors. Secondary colors are yellow, a color called cyan, I think I said that right, and magenta. Okay, and those are primary colors that combine in different amounts. So maybe a lot of red and blue, okay, or red and blue produce this secondary color, and then there's a primary color. So just know that there are primary, meaning the main colors, and then secondary. And then lastly, there's a group of colors called complementary. And that's what happens when a primary color and a secondary color combine and they get white. So it's a complementary color would be your white. All right, last topic is brightness. Okay, and brightness is the intensity of the energy output of the light source. That just makes sense. Okay, if you have a higher wattage light bulb, it's going to be brighter. Okay, so obviously here A has more energy, it is brighter. The brightness is determined by the light wave's amplitude. Remember, we talked about amplitude with sound. That's how high it is, how high its wave is when graphed. Okay? So the greater the amplitude, the brighter the light. Kind of the same, these 2 sentences kind of say the same thing. And then the last comment there is pretty much common sense. The distance from the light source affects its brightness. And that is the end of our slideshow for today. Please remember to go and answer your questions. Those are due for Wednesday's work. And as always, how I end any kind of talk to you, if you need me, get a hold of me on Canvas. Take care.